Okay, our next sample problem is going to be SS.C50, and of course SS is spanning sets, so we're still working on spanning sets. In this case, we have three tasks about these two, this vector and this matrix. First, we want to find the span such that the span spans the solutions to the null space for this matrix. Next, we want to show that a particular solution is actually part of that null space. And then finally, we want to write that particular solution as a linear combination of S. Because if S is basically the span of vectors that will represent all possibilities, then if Z is one of them, then Z has to be able to be represented as a linear combo. Okay, well, as always, we want to look for the solution to this as a homogeneous system. So I'm not going to write in the zero column, but that's how we find a null space, is we assume that the matrix is the coefficient matrix of a homogeneous system. So if I row reduce this guy, this is what I get. So it'll be 1, 0, negative 1, negative 1, 0, 1, 1, 2, and all zeros for the last row. Okay, so I get pivot columns in 1 and 2. So my free variables are 3 and 4. So again, it's very similar to the previous one. I basically want to build the solution to this, and then I'll pull out the vectors that are used to build the solution, because those will be the span. So this is what the solution would look like. Again, it's 4 variables, x1, x2, x3, and x4. And those would be equal to, again, I bring the solutions in as a column vector. It isn't really necessary because, of course, they're all zeros. So it's 0 right down the line. Plus, and then we use the free variables, and the free variables are 3 and 4. So it's x3 times its column vector and x4 times its column vector. And these column vectors, this is going to be the span. This is what we're looking for. Okay, well, remember how to build these. 3 and 4 represent themselves. So x3 gets a 1 in its third row and a 0 for x4, and x4 gets a 1 and a 0. And then x1 and 2 we build by basically taking them over to the other side. So these are both negative 1s for x1, so they'd be both 1s. And then for x2, it's 1, 2. It'll be negative 1, negative 2. And there it is, the entire set of solutions to the null set, which is what this guy is. This guy is now an A. Can all be built out of just these two vectors. That's all we need. We need those two and 2 independent variables, and we can build the whole system. That makes this the span. So the span is equal to these two guys, 1, negative 1, 1, 0, together with 1, negative 2, 0, 1, and that's it. So that answers A. That's the span. And then now we show that Z is an element of NA. In other words, can I build this particular solution out of some suitable combination of x3 and x4? So in order to do that, again, it's just x3 and x4 times each other in order to build this guy. So let's build that potential solution. So here's what it would look like. We'd have our solution set, x1, x2, x3, x4 are already built. So it'd be 3, negative 5, 1, and 2. And we want to see if that is equal to x3 times 1, negative 1, 1, 0, and x4. 1, negative 2, 0, and 1. And of course, it's not too hard to see. X3 has to be 1. There it is right there. That's it. And X4 has to be 2. And then we check, is 3 equal to, again, X3 is equal to 1 and X4 is equal to 2. Is it equal to 2 plus 3? Yeah, and then negative 1 times 1 is negative 1, and negative 2 times 2 is or negative 2 times 2 is negative 4. So that'd be negative 5. So there it is. X3 and X4 are guaranteed to produce this when X3 is 1 and X2 is 4. So there it is. All I have to do now to produce the specific linear combo is just write them in. So it would be 3, negative 5, 1, 2, and then that's equal to X3, which is 1, times 1, negative 1, 1, 0, plus, and that has to be 2, times 1, negative 2, 0, 1. So there it is. Z is actually an element of the null set because it makes it true, and here's Z written as a linear combination of the span. And there's the span.